going to explain the tangent half angle substitution, where it is coming from. So let's start to understand what it means to have the half angle. Let's say we have a triangle here, and we have another subtriangle internally. The distance from here to here, let's say this is 1, okay? And this part, let's call it C, right? This angle that we have here is theta over 2, and the one that we have here is theta, right? The height of the triangle is t in this case, so we need to figure it out the other sides, right? Of course, this will be 1 minus c, right? This one will be 180 degrees minus theta, right? So what will be this one? The sum of all the angles have to be 180, right? So we have 180 minus, of course we have this theta and a half, minus 180 minus theta, right? So we do the operation here, plus theta, so this one will go away with this one. We have 1 theta minus the half. We will have that this is the half, the other half of the theta, right? This is the half. So what we can do with these angles? Do you remember the sin of rule, right? I don't know if you remember, but let me just remind here. We have a triangle here with a high edge, and this is a right angle in this particular place, right? So we have here, let's say here we have the alpha, here we have beta, here we have the side 8 and the side B, right? And I can say that the sine of beta is equal to the opposite side, which is h, over the hypotenusa here, that is the A, right? And the same thing for the other side, alpha equal to h over B. And remember that we can move this here, A sine of beta is equal to h, which is equal to B sine alpha. Then if we move this to the other side and this back to here, we will have that sine of beta over B is equal, I mean the proportion of the sine of the angle with the opposite side is the same, sine of alpha over A, right? And we can do also for the other side if we want, but for this case let's keep it short. So in this case we have that this is the angle, right? Sine theta and a half over this, let's put it B here, over B is equal to this angle, sine of the half an angle, right? And the opposite side is C. The only way that these two is an equation is where B is equal to C, right? So in this case, this is not B, this is C, same like this one. Then what? Then use Pythagoras. C squared is equal, right, to t squared plus the other one, right, the square of the other one, 1 minus c squared. Then we can do the algebra here. C squared is equal to t squared plus 1 minus 2 zeta c plus c squared. This one we can simplify it. This is 0 equal to t squared plus 1 minus 2 c. And let's move this to the other side. 2c equals to t squared plus 1. So t squared plus 1 over 2, right? And what is the sign of theta here? Will be the opponent side with the angle, with the hypotenuse, right? So this is t over c, which is t squared plus 1 over 2, right? We can say this is 2t squared plus 1. What will be the cosine here of theta? Will be 1 minus c, right, over the hypotenuse. Okay? So that is 1 minus t squared plus 1 over 2. We have it here, the same thing, t squared plus 1 over 2. And this is 2 minus t squared plus 1 over 2, t plus 1 over 2. We can simplify this, and that will be this minus will go inside with the 1, so we will have 1 minus t squared plus 1, right? This is cosine of theta using the half an angle substitution. So now what? Let's do something different here that we will utilize in a substitution in an integral. If we have a t tangent and a half, which is the original thing that the original substitution that we will do, what it means if I do the derivative of t will have a second square of the half an angle multiplied by half multiplied by derivative of theta. But remember that this is a trigonometric identity, right? Which is 1 plus tangent square of the half an angle, right? 1/2 the theta. But this is tangent of this is t, right? So the derivative of this is equal to 1 plus t squared over 2 multiplied by the derivative of the theta. And if we move this to the other side, we will have 2 dt over 1 plus t squared is equal to the derivative of the angle of theta. And that is the function that we are going to use to do the trigonometric substitution of the half an angle, the tangent half angle.